I'm Jia from EFC Façade Consultant, and actually I'm an engineer. So everything when we start the architecture design, how many different kind of things we need to take into consideration? I'm not sure, but for one thing I'm very sure is for energy saving. The lecture of the point of the lecture we focus on the energy saving. It's passive design. Actually, for energy saving, each time when we talk about energy saving, we have to talk about how the energy transforms from different places, from different spaces. Actually, all the energy will be transformed in three ways. One is radiation, and the other one is convection, and the last one is conduction. So when we design the facade, we suppose that the facade encloses the whole building very well. So every time the convection will be the contribution of the convection is very low. So the two of the most important thing is conduction and the radiation. Let's say the content of the lecture is about this 3 points. One, we will briefly introduce to the influence factors of facade thermal performance, including the weather condition, heat transfer distribution, material selection for transparent area, and applicability for opaque curtain wall material. And of course, for the building, the skylight is another point. So this could be the sixth part of the lecture. For passive design, we divided the aspect into four different ways. One is the weather condition, and the other one is window wall ratio. And for transparent curtain wall material, we have so many different factors. And for opaque curtain wall, we have some other different factor to analysis. Of course, for the transparent curtain wall, the most important thing is we need to take the radiation into consideration. So direct solar gain is the most important of them, and the other one is conduction also, because as we all know, the glass, the U value of glass is not so good as some opaque wall. So this is another way we need to take into consideration. And for opaque curtain wall, the most important one is about the conduction. And also, the indirect solar gain is a very smaller part we need to take into consideration. So this is a very special case in Wuhan city. This is the rendering, and this is the plan. The design is facing to the north side. So this is the plan. And for the weather conditions, we have four different topics. We choose 5 different cities from the country, because even a very same design, a very same building, when we place the building into different places, the energy behavior will become different. So we choose the Harbin from very north of China. It's a very severe cold zone. And we also choose the Haikou, a very hot zone from China, to analyze the very same project. What is the difference between the places? According to the diagonal here, we can see that Haikou and Kunming, the temperature are very consistent, but Haikou's temperature is a little bit higher than Kunming. But in Harbin, Beijing, and Wuhan, they have a very clear 4 seasons. In winter it's cold, and in summer it's hot. So we have the temperature changing range for the chart. We can see from the chart the hottest month in Harbin is 25 degrees, but the coldest month in Harbin it's minus 16. This is the total direct solar radiation for the 4 elevation in different cities. We can see from the chart, the first chart, that in summer season, when in summer season, Haikou and Kunming, the west elevation, we have a very high sun solar radiation. So when we start our design, we have to focus on the west side of the elevation to control the elevation to control the radiation. But in winter day, we can see the south elevation is the radiation is very high, so we have to focus the radiation in the south. This is the total direct solar radiation of building with different orientation in Wuhan, because as we see from the previous plan, this building is not facing right to the south or right to the north, so they have a certain degree from the north. When we analyze this case, it shows that the direction. It shows that the summer and the winter, the direct solar radiation for the four elevation it's not changed so much. For the third point, we will talk about the heat transfer distribution, including A, heat transfer distribution for facade in different cities during daytime, and B, during nighttime, and also C, the window wall ratio, and D, the case study. Of course, because the building have different purpose. Like the office, most of the time we use the office at the daytime. Like the hotel, we use the hotel most of the time in the hotel at the nighttime because we need to have a rest in it. So we can separate different times for analysis for different purpose of the building. And for the third thing is about the window wall ratio, because right now many different architects need to use glass as one of the most important material for the elevation. But what ratio is the best ratio, or in a certain ratio, what will handle the different glass, like what the glass we will choose from the library. So we can figure out from the window wall ratio. That's a chart for the heat transfer distribution in the daytime, that we can say that the 5 different cities, we have very high direct solar gains in the summer time, in under the 60% of window wall ratio. But in the winter time, the conduction comes to the very important factor we need to take into consideration. So every time when we choose the window wall ratio, when it is fixed, we need to focus on SC, that is called sun coefficient, and the U value, that is accordingate to the conduction. This is at the night time, so most of the contribution is from the conduction. And for the different window wall ratio, we can see different behavior from different cities, like Harbin. When we increase the window wall ratio to 80%, the direct solar gains increase a lot according to the increase of percentage. And also in Kunming, in Haikou, in Wuhan, in Beijing. But for the conduction, we can see different cities have different behaviors. Like we can see the Harbin and Kunming, the indirect solar gain and the conduction are very low. But in Beijing and Wuhan and Haikou, we can see different conductions. So every different cities, we need to focus on different window wall ratio. But in winter day, comes to another situation. The Harbin conduction could be very large because the buildings lose their energy, is losing their heat. But in Haikou and Kunming, the heat is almost, the conduction is almost at the zero level. So when we figure out different point to focus, we need to analyze different kind of window wall ratio. And under different kind of window wall ratio, what is the behavior of U value? What is the behavior of solar gain? So we can say that from the 20% window wall ratio, we can see that the the figure of conduction and the direct solar gain, they're equal, almost equal. So this is almost the same level question we need to figure out. But when we design the building with many different kind of glasses, the window wall ratio increased to 57%. The direct solar gains increase a lot, and the conduction increase a little bit. So at this time, we need to focus on the direct solar gain. That is the case study. And for material selection, for transparent area, we separate. Actually, it's many different factors. We separate them into different aspects. Like we have to follow different kind of codes. The code in USA and the code in Europe and the code in maybe in China. It's different codes. And also, when we select the glass, we have to use the different specs of the glass, like U value, SC, and the thickness of the air layer, and many different aspects. And for the other things is we need to take the sound shading into consideration. That from I to Q is almost about sound shading. For the final one is the contribution of curtain. This is the difference between different codes. Like here, the US code have two different seasons, one in winter and one in summer. But Europe and China codes only have one way to define the different U value and define how the performance is. So when we design the building, or when we use the different kind of glass, we have to calculate the U value and the SC value according to the code. But different code leads to different result. Like here, we can say a normal DGU is at the outside of the building is a glass, and then it's air interlayer, and then it's a glass inside. So it's like some kind of sandwich panel. The U value of glass is a little bit complicated because it's not so. It's not like a very solid material, like a brick or like something else. We can calculate the U value directly. But for the glass, we have to test the U value. It's not calculate. So when we test the U value, the thickness of air layer, it behave a difference. When we increase the air layer from 3 millimeters to 24 millimeters, according to the very very beginning concept, it should decrease from a high level to a very low level. But only US code summertime, it goes down from the very top to the very bottom. But for the US code in wintertime and Europe code and China code, they have a turning point here. So it's not, for the glass, it's not the thicker, the better. It looks like there is a turning point. So 12 millimeters glass for the air layer is a preferred option. But what leads to this result? Actually, in summertime, the temperature difference from outside the building and inside building is not so much. So the convection inside the air layer is not so activated. So in summertime, when we increase the thickness of the air, we lower the U value of the glass panel. But in winter time, the inside of the building and the outside of the building, the temperature is a little bit different. The temperature difference is very high, so the convection of the air layer will be activated. So when we increase the air layer, the air will be activate very freely. So there is a turning point here. So this is the one thing we need to pay attention. So when we choose the glass for a very hot zone in a very hot city, we can choose as thicker as possible. When we choose the glass for a city maybe that is very cold in winter or maybe it's very hot in summer, we'd better pay attention to this chart. So maybe 12 millimeters is a very critical, is a very very best things we need to choose. And also, for the low E coating, we have 4 different surfaces from outside to the inside of the building. We can say that the very outside, the glass is surface 1, and this one is surface 2, surface 3, and surface 4. So the low E coating normally is at the surface 2 or maybe at the surface 3. But when the position difference leads to different kind of SC value. So when we choose different kind of glass, we will have to pay attention about the SC, because SC controls the solar radiation. How many the lower SC value controls the more sun radiation into the building. And of course, besides low E coating and the color of the glass, different kind of freight will affect the SC value also. So we can calculate white freight with 30% density and 50% and 70%. The SC value will decrease from 0.41 to 0.28. So we we found out different kind of glass. One is ordinary double glaze, and the other one is high transparency low E glass. Actually, this high transparency low E glass have a very high SC value. So many different many light will transmit the glass from outside to inside, and the sun low E glass will control the light from transparent. Double silver low E glass will have a better U value, and the insulating glass with double air layer have the best U value. So in different cities, we will have different kind of choice. So this is the we rank the glass with 1 to 5. 1 is suggested glass, 5 is not suggested. So according to the analysis in Harbin, Beijing, Wuhan, we have to choose actually this is decided by U value. We have to choose the glass with the very best U value glass, and in Haikou and Kunming, we have to choose the glass with the very best SC value. So actually this is a different according to the position of the city. But when we talk about the glass, it's only glass, but the architects have their own way to design the building. So we have another aspect need to take into consideration. It's external sun coefficient, because we can have horizontal sun shading, or we can also have vertical sun shading. Different kind of sun shading will expect the building have different SC value. So when the SC value affect the glass, we will have different kind of choice for the glass material. This is another factor we need to talk about. That is the division. Many architects says that I need a division as big as possible because this is transparent. We will have a very good view of the building or something like that. But sometimes the architects need some figures to describe their design, like they need more vertical lines or more horizontal lines. So this chart we will talk about the division. When we start our division from 700 to 2.1 meters, the size of edge will decide how many spaces we keep for the spandrel or we keep for the shadow box, and also will decide how the frequency of the mounting of the facade, and the width is from 1.5 meters to 2.5. So the different kind of division will affect the different kind of the facade for the performance. So it leads to different U value and a different SC value for the whole building. When we apply the division into different cities, we get this diagonal. So we will have Harbin, Beijing, Wuhan, and Haikou, Kunming. We can see this chart that the energy consumption in Kunming, the smaller division, the better. But for Harbin, Beijing, and Wuhan, Actually, the bigger division is a little bit better. But Beijing and Wuhan is not so obvious. So according to different places, we will have different, we can have different division of the building when we design the glass or when we design the elevation. This is for the different type of the system, because many architects will have their own way to design the building, and also for the facade industry, they will have different system to apply it for the building. Like we have a unitized system, we have a stick system, we have glass fin, we have spiders. So different kind of system at the same situation, at the same city, will lead to different U value and different SC value. So this is a normal chart for different kind of facade system. This is even at the same facade system, we will handle detail differently. So for the thermal break, we will increase the thickness of the thermal break. We can increase the air layer. We can fill the foam into some of the chart. So it leads to different U value. But in the most of the way, the architects need to design their building in a unique way. Like we have some recesses here. The glass is not in the plane. It's being recessed by certain places. When we recess the glass a certain distance, we need to pay attention about the cold bridge, because the glass is okay. The glass, we can have a U value, very good U value performance. But for the detail, we will have a problem to handle the details. And for the sun shading seasons, actually we have 4 aspects. Normally, when these 4 aspects matches, the sun shading is being suggested to be applied. Like the first aspect is the temperature greater than 29 centigrade. The direct solar radiation is more than 280. The direct solar radiation duration is more than 1 hour. The indoor depth of solar radiation is more than 0.5 meters. When all the four condition matches, we suggest to use the sun shading. So that is called sun shading seasons. So different cities will have a different result. From this chart, we can see that Harbin disappeared, because Harbin never reached 29 centigrade. The temperature in Harbin is very low, so it's not necessary for this kind of city to set up some sun shading here. And also, when we need to control the solar radiation, we need to put some vertical louvers or some horizontal louvers. This is the result of the louvers, how we put the louvers inside in the building, or what the louvers angle is the best angle, or the louvers length, what length is the best length. And of course, we will have certain distance between louvers to louvers, so we will analyze the different kind of distance for the result. And this is for the Wuhan project. So, and for another thing is about the perforated ratio. When the building is covered by some shield, like perforated aluminum panel or perforated stainless panel, we will have a certain perforated ratio. Actually, we can calculate a different kind of ratio to match the four conditions, like we previously mentioned. So in Beijing, with the west side and the south side, we will have the perforated ratio being suggested less than 34% and 75%. And the east side and north side is not necessary for this kind of theme, or maybe it's designed by the architecture. This is the contribution of curtain. So different kind of curtain. In summertime, it's very useful to block the the direct solar again. But in winter time, we need to put the solar put the solar energy as much as possible inside the building. So the curtain is a very good way to use for the building. And the applicability for opaque curtain wall material construction is about the U value. Is mainly about the U value. So we can see three different kind of constructions. One is about the cladding with the insulation, but without the air layer. This is with the air layer. This is the double foiled. So we will have a different kind of result for different kind of details. Even it looks it looks the same for the building. And so for the brick wall, this is have some impact for the indirect solar gain. But indirect solar gain is a very, very minor part of the energy transmission. And also, when we choose different kind of material, like a polished granite, dark gray aluminum panel, or silver aluminum panel, will cause different kind of indirect solar gain for the building. The difference actually is a little bit very high here. This is the passive design for Skylight. Actually, for Skylight, we have to talk about the glass, because the glass, when it's placed vertically, the convection is in this direction. But when we place the glass horizontal, when we lay down the glass, the convection is in this kind of direction. So the convection will be very fast. So the U value of a very same glass panel is different. So this is the choice of the glass panel. And this is sun shading. This is the self-shading of the building. Actually, we can design the skylight according to different kind of in different kind of way, but according to the solar radiation in summer. So we can use a consistent height of louvers, or we can use the various height of the louvers according to the radius of summer. So we will get different kind of energy consumption here. That's for another way. So that's for all the lecture here. Thank you.
Thank you.